Okay, people, we are up to Chapter 16 in the Psych 400 course pack. Chapter 16 is SEM1, Path Analysis with Manifest Variables. SEM stands for Structural Equation Modeling. This is the most primitive, the most basic form of structural equation modeling. We'll build on it when we get to Chapter 17 with SEM2, confirmatory factor analysis. But let's begin with the basics. We're going to skip over this chapter's terra incognita. A lot of this is not going to make a whole lot of sense until we actually get into it. So let's instead begin with the basics. I am on page 2 of chapter 16. I have filled in the blanks. Whatever items have been blanked out in your course pack, I filled them in with red font here. I've also highlighted the most important parts. Basics of this statistical procedure. Path analysis is a highly flexible statistical procedure which allows researchers to test causal models by analyzing correlational data. It requires researcher be very familiar with previous research and use that familiarity to develop a theoretical path model, simplified representation of the hypothesized causal relationships between the relevant variables. Researcher then analyzes data from a sample of participants and determines whether the actual relationships between the variables are consistent with the relationships that were predicted by the theoretical path model. Because it's based on correlational research designs, path analysis typically doesn't provide evidence of cause and effect that's as persuasive as evidence provided by true experiments. I'll have more to say about that a little bit later. Let's skip down to page 3. I'm most of the way down page 3. Illustrative example. This chapter illustrates path analysis with manifest variables by estimating 3 competing causal models related to health and physical exercise. In each model, the ultimate criterion variable is exercise sessions, number of times participants engage in aerobic exercise each week. The researcher, Dr. O'Day, of course, wants to identify variables which cause people to engage in exercise. Based on a review of theory and previous research, she believes that she's identified the 5 variables which affect exercise behavior. We go to page 4 in the section Primary Theoretical Model. Figure 16.1 presents Dr. O'Day's hypothesized causal model. It'll serve as the primary theoretical model to be tested in this chapter. This is the primary theoretical model that we'll spend most of the chapter talking about. Most of the variables here will be familiar to you. There's just one new variable that I've added. First, let's begin at the end. At the end is the ultimate criterion variable that Dr. O'Day is trying to predict. It is exercise sessions, the number of times per week that the person engages in aerobic exercise for at least 15 minutes. She believes it'll be directly determined by health motivation. She thinks health motivation will have a positive effect on exercise sessions. Higher you score on health motivation, the more you'll exercise. She believes it'll be negatively influenced by dislike of exercise. Notice we have a negative symbol here. Higher you score on dislike of exercise, the fewer exercise sessions you'll engage in. She believes health motivation is positively determined by the desire to be thin and positively determined by current health. Current health is the one new variable that I've added to this theoretical model that goes beyond the 4-factor model of exercise behavior that we spent most of the semester talking about. Dislike of exercise is directly determined by current health. Notice it's expected to have a negative effect on how much you dislike exercise, and dislike of exercise is positively determined by lack of time for exercise. Notice the positive symbol there. This is our primary path model that we'll spend most of the chapter talking about. Let's skip down to page 5, halfway down. The terminology of path analysis. Antecedent versus consequent variables. Each of the variables in figure 16.1 is an antecedent variable, a consequent variable, or both. First, an antecedent variable is a variable that precedes another variable in the causal chains. For example, you can see that desire to be thin is antecedent to health motivation. What does he mean by that? Desire to be thin. Desire to be thin comes before health motivation in the causal chain, so desire to be thin is an antecedent variable. On the other hand, a consequent variable is a variable that comes after another variable in the causal chain. You can see that exercise sessions is a consequent variable to health motivation. Back to our original model, exercise sessions comes after health motivation in the causal chain, so exercise sessions is a consequent variable. Back to page 5. The straight, single-headed arrows on the model represent direct effects. The prediction that an antecedent variable exerts causal influence on a consequent variable in a direct fashion, that is, in a fashion that's not mediated by any go-between variables. We'll have more to say about this business of being mediated by go-between variables later, but right now let's focus on direct effects. The sign and size of the arrow indicates whether the antecedent variables hypothesize they have a positive effect or a negative effect. Positive sign means that high values on the antecedent variable are predicted to be associated with higher values on the consequent variable. Negative sign means higher values on the antecedent are predicted to be associated with lower values on the consequent. What is he talking about? These straight single-headed arrows represent direct effects. Health motivation expected to have a positive direct effect on exercise sessions. Dislike of exercise is predicted to have a negative direct effect on exercise sessions. Straight single-headed arrows represent the prediction of direct effects. Still on page 5, toward the bottom of page 5. Residual terms. The symbols E1, E2, and E3 in the figure represent residual terms. Residual term for a given variable represents the variance in that variable that's not accounted for by the other variables included in the model. Back to our model. Notice we have a little E1 with an arrow pointing at exercise sessions. This E1 is the error term, the residual term. Although we have a number of variables that are expected to have an effect on exercise sessions, variables like health motivation and dislike of exercise, we don't believe that 100% of the variance in exercise sessions is going to be accounted for by these predictor variables. We know there's going to be some variance that's not accounted for by these predictor variables, and this E term, this residual term, this error term, represents variance that's not accounted for by the other predictors. It represents other sources of variance as well, but just think of it as being error variance not accounted for by the predictors in our model. Let's continue. We're on page 6 of the chapter. Research questions addressed. Path analysis with manifest variables, the type of path analysis that we're talking about in this chapter, allows you to investigate questions such as the following. Things like, overall, does my theoretical path model provide a good fit to the data? Does adding a new path model to the model result in a significant improvement in the model's fit to the data? If my theoretical model hypothesizes that one variable has a direct effect on another variable, is the path coefficient for that relationship significant, substantial, and in the predicted direction? And which antecedent variables appear to have the strongest total effects on the consequent variables? Those are the kinds of research questions that we can answer using path analysis with manifest variables, and we'll get to each of those research questions in turn. This is a good place for me to stop this one video. This will be part 1 of my video lecture on chapter 16. Stay tuned for part 2, the part 2 video that will pick up where this one left off.